Hello students, let's start the discussion of the physics test paper based on motion in graph. We have already discussed few very interesting problems based on this particular chapter in our regular live classes, and I believe that you have learned so many things, but as you know, there is no end to conceptual point learning. The more we learn, the more we can come to know about many more interesting points relating to it. So that's why let's have the discussion based on those 5 questions. So first question was based on the argument regarding the VT diagram drawing, right, where question was I think the question which I gave you, that was something like this: a particle is projected vertically upward, right, and it returns to the ground in time t. That means total time of journey from the instant of projection to till it reaches returns back to ground, that is given, and we have been asked to draw the VT diagram of this. Fine. So that means from horizontal level, if you throw a particle vertically upwards, so definitely you will be throwing it with a certain initial velocity. If you don't throw it with any initial velocity, then obviously you can't throw it against gravity. So once you are throwing it vertically upward, that means when you are throwing it vertically upward on the particle, the acceleration g meter per second square, the gravitational acceleration g will definitely act from the starting instant onwards. Even before you throw it, its weight is measurable, its weight is countable. That means acceleration due to gravity is available from the starting stopwatch moment onwards. So I can say that whenever a particle is under the presence of constant acceleration or retardation, right, we can apply the arguments of general equation of kinematics: V is equal to U plus AT, or S is equal to UT plus half AT square. I have already discussed these things in our regular class. So here also the particle being thrown vertically upward with the initial velocity u, as because it is going against the gravity, g is acting vertically downward. So obviously while going upward, I can write down this way: while going upward, instantaneous velocity means velocity at any time t, instantaneous velocity, that is called instantaneous, that is velocity at any instant during the motion. So instantaneous velocity, that can be written u minus gt, because particle is thrown upward, it is going upward, but g is acting vertically downward. So the upward velocity, this implies that upward velocity magnitude will decrease with time, and a moment will come when v instantaneous going upward, which is written as u minus gt, will become 0 sometime. When? Because initially u is having some positive value, and from t equal to 0 onwards, this minus gt part will keep on increasing its magnitude the more we consider time. So a time will come when u minus gt value will be 0. That means once you are throwing it, after moving to a certain height, let it is gaining a vertical height h. So if the initial point A, let this point is considered b, so velocity at b, when it reaches b, it will be 0. Particle will reach to 0 velocity when it reaches the topmost position of this upward journey, and during the motion, at every time G will be available on it acting downward even when it is at the topmost position, when its instantaneous velocity is 0. At the topmost point where it reaches with 0 velocity, there also the acceleration, that is G, that will available on it in the downward direction. So that means final velocity going upward will become 0, but do you believe that the particle will remain at rest for any period of time? Of course not, because the presence of G will now immediately pull it downward. So the downward journey is concerned, it will start with initial velocity 0. It ended the upward velocity, upward motion reaching a 0 velocity, and from that point onwards it will further start falling down with 0 velocity, and during the downward motion now G, the same value of G will now act downward as it was available or acting downward even when the particle was going vertically upward. So either it is upward motion or the downward motion is concerned, G is always available in one direction, that is downward, and in constant magnitude. So I can say this implies that upward and downward motion, includes upward and downward motion includes constant presence of G in the downward direction. Right. So now we will see that while going downward, the velocity magnitude will again keep on increasing. While going downward, the instantaneous velocity will again start increasing from 0 onwards. So regarding the Vt graph, now we can comment on like this. During the upward motion, velocity value was positive, though it was decreasing in magnitude. So what we can do, if we draw the time axis as the horizontal line, and if we draw the vertical line as the y-axis as the vertical line, that is the velocity line. If we draw the velocity line along the vertical line y-axis, so during the upward motion, the Vt part can be drawn with a straight line whose slope will be decided negative. Why it is negative? Because we know that slope of Vt graph, we have already learned about this concept. Slope of Vt graph is acceleration, which is downward, means negative for upward journey. I can consider it like this. During the upward motion, during the upward journey, being the acceleration acting vertically downward, so we can consider downward as negative, and the velocity upward is positive, so that positive magnitude of velocity is decreasing. This is the u value. Positive velocity is decreasing, but it remains positive up to a certain time, right? So when it reaches to the topmost point, that time the velocity is 0. So this point will be half of the total time of flight, because we know that when a upward followed by a downward journey completes in presence of the constant presence of acceleration, so during the upward and downward journey for equal displacement, it takes equal time. So out of the total time of flight, which is given capital T, so half of the time will be spent in going upward, and as because the acceleration remains same in direction as well as same in value, so that's why during the downward motion, we can continue the straight line with the same slope. We can continue the straight line with the same slope up to t is equal to capital T, and while reaching the ground, it will reach the same velocity magnitude, but that will be negative. So you can see that after t by 2, this part is the upward journey, this is representing the upward journey, and this part is relating to the downward journey, and overall Vt graph will be represented by a straight line, because slope is throughout same, either it is upward journey or downward journey is concerned, because you can see g remains constant, either particle going upward or it is coming back downward towards the ground. So are you getting it? So this will be the velocity time graph under the motion under gravity when it is thrown with certain velocity and it returns back to the point of projection, that is ground, after a certain time. So half of the total time of journey will be spent in going upward and rest half will be used in coming downward to the starting point. Is that okay? Yeah, so this will be the answer of the first question. I have written all the possible things to make you understand, and actual diagram, the graph will be this much. Okay, so let's move to the next one.